This book is um, kind of an historical compilation of all the work in astronomy that has led up to the present um, position that we have regarding physics. And although you can't see it very clearly, I think moving the book closer doesn't help much, but basically it's divided into different parts where you look at the ancients. So the heroic age, part one, is about the ancients, and that's the part that we actually need to look into a little bit to understand uh, where did all this begin from. So basically, it's the story of physics, right? And what was the first question? What was the question that human beings had in mind that led them to invent or discover, as the case may be, this entire theoretical science, which kind of helps us move closer towards the answer to that question, which is basically where are we, why are we here? Okay, what is this? What holds all of these things together? Where did it come from, and where is it going? Okay, and then having looked at quickly through the ancient history, we move into three characters in the story, which brings us to the point from where we start looking at Newton's work, which is what the classical mechanics course is about. So the people that we need, that we will look at a little bit more in detail, will be the work of Copernicus, whom of course you would have heard of, Kepler, whose name also you would have heard, and finally coming to Galileo. Okay, and following quickly from the work of Galileo will be Newton. So basically I want to draw the framework, the history behind which Newton did his work. As Newton himself has said, he said that I could see as far as, I'm paraphrasing it, I could see as far as I could because I stood on the shoulder of giants. Have you heard this quote somewhere before?
Yes, sir. In
Yes,
the
sir.
last year's
Yes,
science.
sir.
Last year.
Last to last year. Okay.
Yeah,
Yeah.
we
So
had heard it in our science classes. Last year.
so the context in which Newton made that quotation is what we are kind of trying to look at now. So we start with the oldest conception that we know about. We do not know prehistorically, that is before history was written, how the people imagined the world. So we can only start from where we have some kind of an evidence, some kind of a record of what the universe was like. And in that, one of the first people who come to mind are the Babylonians. Okay? And the Babylonians naturally thought of the earth as being something of a flat object, okay, on which everything that we know of exists. So whether it is mountains or rivers in between mountains and the settlements in which we live. Okay, this is of course not in any way to any kind of a scale, because obviously if mountains are that big, then human beings have to be much smaller. But you get the general idea of how they imagine the world to be. And then surrounding this, the whole thing floated on another disk, right, which contained the oceans.
Sir,
Yeah.
sir, Prakriti is saying that she can't see anything. She has some problems.
You have a problem with seeing the screen.
Sir, Prakriti is saying that.
Yeah, so Prakriti, can you say something? What is the issue? Then maybe we can solve it.
She's not here, I think. The 38 people.
So if she's not here, then obviously she can't see the screen. So let her join in.
Yeah, sure.
Please send her a message asking her to join in. And the moment she comes in, I will let her in.
Sure, I have a question.
Yeah.
Yeah, so like the Babylonians imagined. So I think like I'm not sure, but could it be when like the time of the Babylonians that the Pangea was there and not the separate continents?
Well, the Pangean concept is something that came later. Um, I think isn't that doesn't that have some Egyptian origin? The idea of Pangea?
It
I'm
was
not sure, sir.
Okay. So basically the idea was that there was one unified landmass which was flat, connected, and it was floating on a container of water. Okay. So therefore the whole thing now has an edge. So there is a boundary which there is to it, and if you naturally go beyond the boundaries, then you will fall off it. Okay. Now, what was missing in this conception? This is fine, right? If I told you that this is how everything is, what was missing in this conception? And I can say that, well, you can verify any of these things if you want. All you have to do is, Prakriti is now coming in. All you have to do is walk right to the edge of the landmass. You can test this out. You keep walking, you keep walking, you keep walking, and you will come to the edge of the landmass, and you can see the waters. So if you stand here and you see, right, as far as the eye can see, you will see water, and then you will see the horizon, and beyond the horizon, right, there is nothingness. And then if you took a boat and you sailed, right, you can sail as far as the edge of the world, and beyond that you will fall off the planet. Okay. And obviously this is a very difficult thing to do, but if somebody really wanted the answer to the question, is it really like this, then this is what you have to do. So what other things that can be seen are not explained over here. So let's build this model a little bit more. This is the basic idea. What's not here? The stars and the sun.
Yeah.
The stars, the sun. Okay, let's make a list of all these things, and we will see if we can fit everything into this model. Okay. So what's missing? The stars, the sun. Anything else?
The islands.
The islands are there. That's not very hard to fit in.
The
So
moon.
planets.
Yeah, the moon, and yes, somebody did
The
mention
sky.
the planets, the sky, of course.
The clouds.
Yes. Sun I have written already. Anything else? Okay. So where do we, let's go in the same order that there is, we might shift the order a little bit, but let's kind of go in that order. Where are the stars? Where do I place them? In the sky. In the sky, up here, right? So I put the stars out here. Hey, by the way, Namit, I'm still waiting for an answer to my question. How many stars? Okay, I put the stars. So you can, anybody who looks up at night will be able to see these stars. Then, what else? Come on, we haven't got all. Clouds. Okay, let's put the clouds. So,
Sir,
clouds. Yeah,
there I have a question about the diagram.
yeah. Ask. So,
I have a question of what you've drawn. So is this piece of land just floating in air or does it have some bottom?
uh, it's a kind of a huge container with water in it, and the land mass is floating on the water.
Oh, okay.
Sir,
Let's make it as we go along. Okay, I'm just cooking all this up. I started with the Babylonian model, and then we'll take it as our imagination goes. Yeah,
sir,
yeah.
so were the Babylonians only the ones who thought that the means what do you call the flat Earth? What they thought was there, it
Yeah.
was on a cow.
Yeah. Some of them imagined it like that, but we will come to that a little later. That is the part where we discuss the sky. Okay, so clouds are there. So stars are done, clouds are done.
Moon.
The sun.
Okay, the sun. Now the sun is a problem. Okay, why? You tell me why. Where do I?
Because the stars can't come like can't be seen with the sun
Yeah,
because
that,
the sun is too
yeah.
because
So
the sun is too bright.
correct. So we can always say that the sun is very bright. So therefore, when the sun is there, we can't see the stars. Okay. So that's taken care of. Actually, the problem of day and night also gets sorted out in this.
That was my answer.
So I'm saying, where do I put the sun?
On the other side.
What do you mean other side?
So you can put it anywhere
Over
and
there,
then make a
basically.
line which is around this container. So it will show that the sun is revolving around this earth.
Exactly. So, unlike most of the other things that we have put over here, the moment you introduce motion, right, there is an issue. You have to explain why the motion takes place. And what is it that we notice about the sun? The sun rises at a specific direction, not always the same direction, but we'll talk about that later. It rises in a specific direction and then it makes its journey across the sky and then it disappears in the opposite direction. Okay, so therefore there is a movement which we can see with our own eyes on a daily basis. So there is no fixed position for the sun, unlike the stars. Okay, the stars seem to be more or less in a fixed position, right? How do we know that? We know that because the ancients also looked at the stars, made careful sky charts, and noticed that there were constellations. Constellations means a fixed number of stars that always held the same position for as long as human beings have seen it. Okay, so the stars could be more or less fixed in their place in heaven, but the sun and the moon, both of them, don't have this. Okay, so therefore we can put the sun wherever we like. As I don't know who said it, somebody said it. Okay, but the problem is that the sun also makes its way across like that. I could also show it like this, but then I won't be able to draw it in 3 dimensions. So I'm showing it like this, with this being the direction in which the sun moves. Okay, but now the problem is that, okay, it's moving, but how is it moving? Okay, we have that question. We have not answered it yet, but let's wait for it. There is a problem that comes because of motion. When we introduce motion, we have to explain it. Who is moving it? How is it being moved? What is it moving on? Okay, so we'll hold that. And then the moon. So the sun I have put over here. Where do I put the moon?
Opposite of the sun.
Sorry, opposite to the sun. Yeah, that seems to make sense. Why? Because the moon is not usually there. I should put it like that. When the sun is there. Okay, so one good solution will be to, let's say, put the moon like somewhere there. Okay, so that's the moon. And what about the motion of the moon? What do I do about that? Or shall I deal with it later?
Same direction
Deal
as
with it
sun.
later.
Deal with it later. Okay. When things make a problem, we will deal with it later. Okay. So now let's look at our list. So we have put the sun and we have also given it a path. We have put the moon, but we have only dealt with it halfway. What about the sky? Let's come to the planets the last. What about the sky?
There's a problem with the moon.
What is the problem with the moon?
The moon changes its shape.
Exactly. So there are lots of problems. Now,
And
the,
so I want to say something.
yeah, just a moment. Okay, let's list the problems. Okay, so the moon's shape, we have to explain the shape of the moon, and we also have to give the reason for the motion.
Sir, I have an explanation for
Yeah,
the moon ka shape.
yeah. Go ahead.
So there's a cloud in front of the moon. So the cloud is thick enough to hide the light of the moon, and it changes. So the moon ka shape changes.
Okay.
I have a better one.
Yeah. So, okay. So you are giving a possible explanation for why the shape of the moon changes.
Yeah.
Sir, I also have an explanation.
Yeah.
But then let us go one by one. Okay, each idea that every individual gives, okay, we should all focus attention on that particular idea. Of course, you may have ideas on your own. I hope you are having a notebook or something to write in front of you. I suggest a notebook so that whatever ideas you are getting about this, you also note it down in your notebook. Okay, so you don't forget it. But when somebody speaks and they give us a certain proposition, then we should focus on that proposition and try to think it through. Okay, there are lots and lots of questions about each one of these things that is being mentioned over here. Nitin is here finally. Okay, listen carefully, give attention to their solution, and see, okay, what you have to say about it. So Ruhani says that the clouds are the ones that are responsible for the moon's shape. So my immediate answer to that would be, there are times when there are no clouds in the way, but still I see that the moon changes its shape. In fact, I have been watching the moon for the entire year, and moon's shape, regardless of whether there are clouds or not, seems to take some specific shapes. If you like, I can even draw it for you. So the moon appears full, and then it starts to reduce, and then it becomes almost a sliver of itself, and then the whole thing repeats backwards. So it goes forwards and backwards in this manner. Okay,
Waxing and waning.
and sometimes there are clouds, sometimes there
Sir,
are.
but there's always a cloud with the moon. There's always a cloud with the moon. You can't see it, but
Now,
there's always one.
come on, Ruhani, you can't tell me that there's always a cloud with the moon. I have seen.
Sir, I have a question.
One moment, one moment. Let me just finish my point, then you can ask your question. I have seen the moon for days together on winter nights. Let's say I'm one of those Babylonians. We are Babylonians and we are trying to make this model of where our universe is. The Babylonians have given us the responsibility to tell the rest of the Babylonian world what our position is like. Okay, so we are debating things among ourselves so that we can present a clear picture to them. Okay, so we are debating among ourselves, so we are not fighting with each other or arguing with each other, but we have to arrive at some solution to this. Okay, so I say, me as a Babylonian is telling Ruhani that no, I don't think so. I have seen the moon throughout the year, particularly in winter, when there is no clouds in the sky. I have watched for days on end the moon doing this. And there is no cloud that does this. So there must be some other explanation for what happens. Okay, what is going on, I don't know, but I don't think the clouds have anything to do with it. Okay, so I'm saying that you think about what you have to say about that, about what I have put to you. Now, who wanted to speak?
Thanks.
Somebody else. Yeah.
So me.
Tell your name
Sir,
and
me. Sir, this is Hia.
yeah.
I had a question. What about the seasons?
Uh, we will come to seasons. I'll put seasons down, but we'll come to that. These are all obviously things that we experience directly. So that is why the senses are important in this. So our senses are giving all these different points. And now we need one model to fit all of these things in. Okay. So we will do the best. We'll do the best we can. But right now, seasons is still a question. We'll cross that bridge when we come to it. Okay. Let's try to get one of the things sorted out as clearly as we can. Yes, there was somebody who wanted to ask something.
Me, I was trying to explain.
Name.
Explain. I was trying to explain.
Your name is, I can't see the okay.
My name is Arman.
हाँ ऐसे नहीं मतलब बोलो कि sir Arman here and then speak. Yes, go ahead Arman.
So, sir, like you think, for now example, that there are the sun is means sorry, the earth is here and sun and moon are revolving around it. Means they have a particular orbit where moon has.
Yeah.
But then sun is actually a lot far away from us.
Yeah.
And moon is near. So what happens? Moon can cover its orbit faster. So that's why if you see like how it happens normally, but just I have changed the thing that sun is revolving around us.
Yes.
To make
Very good, very good. I'm glad you mentioned that point, because that was one thing that we will inevitably come across, which is that you have to ask the question, and I'm just going to use another whiteboard over here to just show it in a larger scale. So we have this container and the disk and the things, everything over here. Okay. Now the question is, the sun is here and it has a path. Okay, so in the larger picture we have shown the hemispherical path, but obviously if the sun, wait, let me just draw this a little better. Okay, the sun has to go around, right? It disappears here and then it appears again over here. Okay, so therefore we have to conclude that one way in which we can explain how that happens is by drawing a complete circle, isn't it? So the path is circular. That is why it disappears here and it appears here. So when you see at this plane, people can see it set over here. So this is the setting position. And this is the rising position. Right? You get this. Okay, now we added one more thing to it. We said there is a moon. So now, of course, the question, and let's first put the moon over here. The question is,
I said that the moon is closer to the closer to
what I'm trying to do is I'm trying to illustrate the problem and then give the solution. Is that right? Do you get what I'm trying to say? So if the sun and the moon are part of the same path that they are taking, okay, we are only talking about paths. So there are two questions over here: the path and the position. Okay, so if the sun and the moon are taking the same path, then the question could be asked, well, sometimes we can see that the sun and the moon are there at the same time too. This also happens. The moon is not as bright as it is during the night when this happens, but it's clearly there. Okay, so how can it be that two objects are following the same path, right? They don't run into each other, they don't bang into each other, but they appear at the same time sometimes and also opposite to each other sometimes, which means that one is there and the other is not there. So then Armand solution comes into effect, which is that maybe the path of the moon is different from the path of the sun. It may be closer, it may be further away, because we can also say that it moves faster than the sun. That can also be a reason. But naturally, the simpler thing would be to say that, well, the moon therefore cannot follow the same path as the sun, right? It must be having its own path. Does this make sense? Are you happy with this model, my dear Babylonians?
Yes.
Yes, sir.
Armand the great Babylonian philosopher.
Yes, sir.
It's a new idea. Thank you, Armand the Babylonian. And naturally, the paths are different now, and so is the speed with which they are going around. And that is why we have these things happening. That sometimes they come together, sometimes they come separately. Brilliant. So we have got two different paths. So now we come to an important question, which is the question of position. Okay, I tend to forget how the time goes when we do this kind of thing. So somebody please keep track of time and tell me 5 minutes before the end of class. Okay?
It's already end of class.
Sir, I want to say something.
It is time already.
Sir,
Say
it's
time,
already 3:30.
Yeah.
which means it's 5 minutes. Okay, okay.
Class
The class
over.
ends.
But we can do, if you have time, then we can do.
I'll just wait for the bell. When the bell rings, we'll stop. This is so interesting.
Sir,
Yeah.
I want to say something.
Name. Say it.
Oh,
Name, please.
Shiv here.
Yes, Shiv.
Okay.
Last.
Yeah, sir, I think that there's some problem in the sun here,
Yeah.
because like the earth we have drawn over it is like, no, the Pehla wala board. Yeah. So the earth is like very small compared to the big disk below it.
Okay.
So the sun like must be taking a long time crossing it, like revolving. So there will be like more of night and very less of the day.
No, but that's why I drew this. So you can see that it takes the same amount of time for the day as for the night.
Okay.
Sir,
Okay, so I think we'll stop here now, and I'm sure this has thrown up a lot of questions. So the most important question that we have to ask now, I feel, is what are these things resting on in order to move in this manner? Okay, how is this happening? Okay, because what we see on the earth is that things don't move unless somebody moves them. Okay, so if I put a whiteboard marker over here, then that's not going to move until I make it move. Okay, whereas the sun and the moon and all that seem to be moving with no apparent mover. Okay, and this is something that is mysterious, and we have to answer this. So our job as Babylonian astronomers is as yet undone, and we will try to fix this model in the next class. Is that good?
Sir, I have something to say.
Yes, sir.
So wait just a moment. We will stop here now. Others need a break. So all those who would like to leave now should and can leave. We'll just hang around. I'll hang around a little bit longer for the others.
Class.
Ask
You
something.
hear them talking?
Yeah.
Okay.
What are
And
they
there's a
saying?
class going on?
No,
Which class is it?
Sorry.
that's what. This was Mr. Arun's class.
Yeah.
Okay,
Mr.
so-
Arun is mathematics 9:15 to 10.
But
Why are they there right now? Is it
I'm
is it
just going to-
recorded? Like, is it
This is Arun.
that?
Hello.
no, but Mama,